Imagine 3 hospitals, A, B, and C, with the capacity to handle 5, 20, and 100 births, respectively. You're told that in one of the hospitals, the male births were 100%. In which hospital did this likely happen? A, B, or C? Now keep this in mind as we explore Monte Carlo simulations using a toss coin experiment to get an intuition behind this puzzle. We'll explore how randomness behaves over 5 tosses, 20 tosses, and 100 tosses, and then come back to our hospital puzzle. So what is Monte Carlo simulation? It's a method that uses random sampling to estimate mathematical outcomes. Instead of solving equations, we simulate the process, like tossing a coin many times, and see what results we get. It's all about letting the randomness play out and observing the patterns. Now, let's get our hands dirty with coin tosses. However, we'll do virtual toss coins. Well, how? Listen up. First, we will use the rand function in Excel, which gives a random number between 0 and 1. Next, we will use the if function and ask Excel to produce a number between 0 and 1 using rand. And if the number is less than 0.50, we output a 1, otherwise we output a 0. So essentially, each cell is a virtual toss coin experiment assuming a 50-50 chance of either heads or tail. For simplicity, a 1 means head and 0 means tail. We now set up 3 columns, label them A, B, and C, and do virtual toss coin experiments for 5, 20, and 100 tosses. Now we populate the spreadsheet accordingly, with the formula we created, copying the cell for 5, 20, and 100 cells under each appropriate column. Now let's run this experiment several times, say 20 times, essentially doing a sampling distribution for each column. To do this efficiently, we will create an average formula at the top of each column, along with a count formula to properly tag the columns just below the labels. Now make sure to only average the affected cells under each column. Right, next we set aside a field on the right where we can copy-paste the averages of A, B, C continuously without writing code. What we'll do is copy the average row, paste value into the area we want to place it in, then move down one cell and then press Ctrl Y to redo the action. We are just doing the last action of paste value when we do the Ctrl Y. Note that the spreadsheet recedes, meaning the numbers change every time we paste value, but that's okay. When we're done, we can run averages of the sampling distributions for A, B, and C and show the standard error estimate. Note that the number that will appear in your screen will look different, but the takeaway should be the same. Notice how the averages circle around 50%, though it's not always exactly 50%. Notice how the standard error goes down from A to C, indicating less variation around 50% the more tosses there are. Also take note of the max, min, and the range of the sampling distribution. Makes us see better what's going on. Now, what are your takeaways? Where is there higher variability around 50%? A, B, or C? Now, let's come back to our opening puzzle. Remember the question? In which hospital with 5 births, 20 births, or 100 births is it most likely that every single baby born is a boy? Now, think about our toss coin experiment. Getting all heads is like getting all boys. We know that our simulations show extreme results when there are few tosses. Which hospital is most likely to have all boys? The answer to that, based on these simulations, is Hospital A, the one with 5 births. The fewer the births, the more likely you'll see extreme results, just like flipping a coin and getting all heads in a smaller number of tosses. So what are the key takeaways here? Number one, the small sample sizes are more likely to produce extreme results, and the standard errors are bigger. As the number of trials increases, the results stabilize around the expected probability with smaller standard errors. And Monte Carlo simulations help us visualize and understand randomness and probability in action. By the way, in real life, we need to do thousands upon thousands of simulations rather than just the 20 or so plus that we did here for simplicity and presentation purposes only. But you get the idea. So bonus, we're adding something here to give a closed form solution to the standard error against doing the Monte Carlo simulations. For a coin toss, the standard error of the proportion is given by this formula, where P is the probability of heads and N is the number of tosses. So as N increases, the denominator increases, making the standard error smaller. And here are what the calculations look like for 5, 20, and 100 tosses. Note that our sampling distributions approach these numbers. Try running your own virtual toss coin experiments and see how your results compare with ours, which we expect to be not exactly the same, but statistically similar. The most important thing is, in probability, surprises are more common in small samples. So if you enjoyed this, like and subscribe for more experiments and puzzles. See you next time.